Hi, my name is Daniel Owen, and I'm a geologist with Maptek in our Perth office. Today I'm here to share with you the first phase of our exciting new drill hole planning tool suite. The first phase, including the Evaluate Drill Density and Create Drill Targets tools, is included in the Vulcan 2020.2 release and will be available to all users with a GeoModeler or Geostat Modeler license. This first phase release lays the foundation for the game-changing functionality that I'm going to touch on later in this presentation. These tools are aimed primarily at production geologists, who spend a large portion of their working hours designing and managing drilling operations with the goal to automate monotonous and repetitive tasks and greatly reduce the time required to generate long-term conceptual drilling designs, as well as the day-to-day production designs. The first thing any geologist wants to know when planning drill holes is what their current drilling density is like, i.e., where do I currently have decent coverage of drilling, and where do I need to put some more holes and focus my efforts and budget. So I'll load up some drilling here, and I'll load only the holes that intersect my ore body triangulation. Okay, great, but what I really want to know is what sort of spacing I actually have between these drill holes. This is where I can use the first of our new tools, called Evaluate Drill Density, found under the new Geology Drill Hole Planning menu. So firstly, I'll create myself a specification file and a scenario ID to store my parameters. Next, I'll select my input drill hole database to evaluate from. I could select multiple databases here if I wish. I'm just going to go with one. Then I'll select a triangulation to evaluate the selected drill hole database against. Again, I could select multiple solid or surface triangulations here. I'll also define the max thickness value that represents the max true width for a solid triangulation. If I was using a surface here, this value would represent the maximum undulation or height variation of the surface. It's a really nice image in the help that explains this further, and the value in this box will have a direct correlation to the processing time. So it's best to use a value that's large enough to cover the maximum true thickness, but not just putting a really large value, as that'll just add extra processing time for no real benefit. Next, I'll define my distance thresholds I wish to evaluate against. So in this instance, I want to know how much of my triangulation has a drilling density of 30 metres, 60 metres, 80 metres, 100 metres, and greater than 100 metres. So the values I input here define the diameter of the search from each drill hole intersection within the triangulation. The tool is going to output triangulations that represent my distance thresholds, and I can choose to colour these using an existing legend in my SCD file, or I can select a default base colour from which the colouring will iterate. I'll select my desired output directory for the triangulations and then press OK to run the evaluation. So I'll just remove the input triangulation so we can see the outputs a bit easier. And here we have mutually exclusive triangulations for each distance threshold, and you'll notice that the evaluations are performed rotated relative to the midpoint of the drill hole intersections and a pseudo-mid-surface of the triangulation. This better reflects the actual drill density when factoring in suboptimal angled intersections. So now I can quite quickly see where I need to focus my drill hole planning. So what I can do from here is remove my first distance threshold triangulation, as I don't need any extra drilling in those areas. Then I'm going to merge the rest of the triangulations to give me a triangulation that represents the area I wish to target for further drilling. Now I can use the new Create Drill Hole Targets tool in the Geology Drill Hole Planning menu to create some new target points. So I'll create a spec file and a scenario, then I'll select my input triangulation. Again, I could select multiple triangulations here if I wanted to. The way this tool works is that I define a plane within which to create a grid. The points on this grid are then projected perpendicular to the plane to where they intersect with the triangulation. So to define my plane, I pick an origin point in 3D space. Then I can define the orientation and extents of the plane. Now I define target IDs to build the target grid with the desired pattern and spacing. So firstly, I'll do a 10 by 10 metre resource definition grid, and I'll stagger the targets between each row along strike to create a diced 5 pattern. I can define an optional group and domain flag that will be written to each target point created. These will be able to be used for easily selecting targets based on group, and also for naming drill holes created in the new Create Drill Holes tool that will be available as part of the Phase 2 drill hole planning tools, slated for Vulcan release within the second or third quarter of 2021. I'll also create a grade controlled target ID that I'll offset for my RD pattern at the origin to create an infill pattern. I then define a layer name to save the output target points to, and then use the Preview Targets button to check the target points created to make sure I'm happy with the output before saving and closing the panel. If I put myself into a section view, you can see the effect of the different target point position options. And once I'm happy with my targets, I can press Save and Create Targets to save the specification parameters and save the target points to my selected layer. So it makes for a really quick and easy way to generate drilling targets informed by your current drill spacing. But what else can I do with these new tools? Well, I could use the Create Drill Targets tool to create a mid-surface from an existing solid triangulation. So firstly, I'll load up the scenario I created previously, and I'll use the Save As option to save it as a new scenario, so I don't need to go and define my plane extents and orientation again. I'll change the triangulation to the one I want to create a mid-surface from, and I can delete my GC target ID as I'm just going to create a simple finely spaced grid. Since we're after a mid-surface, I'm going to create the target points in the middle of the solid and create a new layer for the generated points. Obviously this will take a little longer to process than the previous example, as there's significantly more points created and intersections tested across the grid. Now that I've got my midpoints, I can use Design Polygon Edit Boundaries to create a bounding polygon to help in controlling the surface creation. So in this instance, I'll use a projection plane based on 3 points, so the polygon is appropriate for my data. So I'll pick my 3 points to define the plane within which to create the bounding polygon. And then I'll select my layer of midpoints to create a bounding polygon around. I'm happy with that, so we'll save the output. And now I can go to Model, Triangle Surface, Create, and I want to triangulate data projected against a plane, and I want to use a boundary polygon, but I want to exclude my boundary polygon from my data since my bounding polygon isn't snapped to my midpoints. Then I can pick my 3 points to define the projection plane, select my bounding polygon, and then the data I want to create the surface from. I'll give my triangulation a name and a colour. And if I remove my midpoints and my bounding polygon layer, you can see I'm left with a nice mid-surface for my ore body solid. Right, what else can I do with these tools? Well, let's say I'm planning some exploration drilling and I want to create a big grid of collar points across a topographic surface. Again, I can use the Create Drill Targets tool to achieve this. So I'll load up my topo, and then I'll create a new scenario in my spec file. Then I'll define my origin point and extent settings for my grid plane. Once I'm happy with that, I'll create the desired parameters for my collar spacing and a layer to output the collars to. As I mentioned at the start, these two tools represent the first phase of our new suite of drill hole planning tools for Vulcan. With future releases of Vulcan, you'll see the list of tools in the Geology Drill Hole Planning menu increase. The next phase will bring tools to help calculate drill hole deviation rates based off of existing drilling, which along with the collars and targets created from the Phase 1 tools, can then be used in the upcoming Create Drill Holes tool to quickly and easily create deviated drill holes that will reach the desired targets while factoring the expected deviation. You'll also be able to easily name your drill holes with customized naming expressions and orientation settings. Automatically adjust collar locations based on a drill rig setup specification file. Extend your drill holes a desired distance beyond the footwall of a selected triangulation. You'll also be able to create wedge drill holes, complete with navigational drilling. You'll even be able to calculate estimated drilling costs, and then export the drill holes into CAD layers, CSV files, and directly into an ISIS drill hole database. Finally, Phase 3 of our drill hole planning tools, currently slated for second or third quarter 2021, will bring a much requested feature that will allow the easy creation of drill hole hazard cones to help in potential breakthrough interactions. But not only that, you'll also get a report that highlights the hazard objects, how far down the drill hole the interaction is expected, and how close to the drill hole the interaction occurs. So as you can see, there's plenty of innovative development going on at Maptek at the moment, with the goal to make your lives easier and your time using our software more efficient and enjoyable. Thanks for watching, and if you have any questions, please contact your local Maptek office.